For over 200 years, a certain class of math problems has been officially stamped unsolvable. But what if that label was wrong? Today, we are diving into a claim that's looking to rewrite a fundamental chapter of algebra.
Right off the bat, this is the bold statement at the very heart of our explainer today. This comes from a work that claims to have done something mathematicians have believed to be impossible for centuries. It's a direct challenge to a cornerstone of modern math.
I mean, that's a huge question, right? To challenge a principle that's this deeply embedded in our understanding, you need an extraordinary claim, and it has to be backed by an absolutely ironclad new method. So let's explore what that is.
To really get what a big deal this is, we first have to understand the old rule. Let's set the stage and take a look at the monumental barrier that's been standing for 2 whole centuries.
And here it is, Abel's impossibility theorem. You know, for generations of mathematicians, this wasn't just a theory, it was basically a fundamental law. It meant that, yeah, you could solve a quadratic or a cubic equation with a nice, neat formula. But once you hit the 5th degree and higher, no way. No such general formula existed. This theorem defined the absolute limits of what was considered solvable.
This timeline really puts it all into perspective. We are not talking about some recent idea here. For over 200 years, this theorem has been accepted as truth. It's been taught in universities, and it's been foundational to algebraic theory. Challenging it is kind of like challenging gravity.
So with a barrier that high, who would even dare to challenge it? Let's meet the author behind this brand new claim. The claim comes from Professor Mourad Sultan Ezouidi, and it's not a small one. He doesn't just question the theorem, he actually puts forward what he presents as a complete, exact, and symbolic solution for a 7th degree equation, one of the very polynomials that was supposed to be unsolvable by a general formula.
What's really interesting is how this is framed. The claim isn't really that Abel was wrong, but that his theorem was based on an incomplete understanding. It's being positioned as this vital historical step, but, a step that has now been surpassed.
So how is this supposedly impossible feat accomplished? Well, the work proposes a whole new mathematical framework. Let's take a quick look at the key components.
According to the source, the whole solution rests on these 3 pillars. It kicks off with a new foundational theorem, then it uses a method of recursive transformations to break the problem down, and finally, it analyzes the roots using something called discriminant structures. So together, this is the toolkit that is claimed to unlock the unsolvable.
And now for the main event. I mean, theory is one thing, but the source material actually applies this method to a specific and, frankly, formidable-looking 7th degree polynomial.
Okay, here is the beast. This is precisely the kind of equation that Abel's theorem said had no general formulaic solution. Let's see how this proposed method even starts to tackle it.
And the process begins. The source goes into detail on a series of systematic calculations, applying the theorem's transformations step by step.
The recursive method keeps on chugging along, with each stage simplifying the really complex relationships between all the coefficients.
The process is followed all the way through to its conclusion, applying the transformations for all the degrees within the polynomial. And after all that work, something pretty remarkable is claimed to happen. This is the claimed result. The entire complicated polynomial on the left is transformed step by step into the stunningly simple equation you see on the right, x to the power of 7 equals 0. Through this whole process, all those other terms just vanish. So if x to the 7th equals 0, then the solution is pretty obvious, right? The root is 0. And according to the source, this isn't some numerical approximation. It's presented as an exact, symbolic root that was derived through pure algebraic reasoning.
A result like that, if it gets verified by the wider mathematical community, would be way more than just a clever solution. It would fundamentally change the entire landscape of algebra.
This quote really captures the scale of what's being asserted here. The implication is that we've been looking at the problem through the wrong lens, and this new framework gives us a completely different perspective on what solvability even is.
So what does this all mean? Well, it suggests that high-degree polynomials might actually be solvable after all, that Abel's theorem wasn't wrong, but simply one part of a much bigger picture. This could potentially be the dawn of a new era in symbolic math, one that goes beyond what we thought were hard limits. And that is the ultimate question this work leaves us with. It's a profound, revolutionary claim that now has to be examined by the global mathematical community. We've just explained the claim, and now the world is going to watch to see if the proof holds up.